Today we want to talk about hypothesis testing. Now, a claim and a hypothesis mean exactly the same thing. In statistics, we usually use the term hypothesis, but it's just a claim that something is true or not true. Actually, in statistics, that claim will be about a parameter for a random variable. Now, as a first example, I've already written some materials up here. So let's take a look at what's up here. We've got that a claim is equal to a hypothesis, and here's a story that we're going to tell. This is a story from our book. But suppose there's a company called Xsort that claims that their treatment will increase the probability of having a female baby. Now, a null hypothesis is a claim of no change. Everything is just like it was. So without Xsort or any treatment, the probability of a girl birth would be about 0.5. So that would be a null value, a claim of no change in what has been experienced in the past. And we would write H0 for the null hypothesis. So H0 is going to be our null hypothesis. And H0 is equal to that P, the probability of a female birth, is equal to 0.5. But if Xsort works, then the probability P of a girl birth would be greater than 0.5. And this is what we'll call an alternate hypothesis. So the alternate hypothesis is that P is greater than 0.5. Now our job is to take a sample and look at evidence from the sample and decide which of these two hypotheses is most likely to be true. Keep in mind that we're using probability here. We will be able to tell which of the two hypotheses is most likely to be true. But that doesn't mean there won't be some margin of error. We'll be able to adjust how often we will be incorrect by adjusting the value of alpha. Now, let's continue to talk about this for a second, and this is a good time to do some scrolling. You will remember that we have a long-standing rule, we've talked about this since day one, that events with probability less than alpha, where alpha is often taken to be 0.05, but events with smaller probability than alpha are deemed unusual events. Now, here's the setup for our hypothesis test. We have a null hypothesis, that is H0, that P is equal to 0.5, and we have an alternate hypothesis, HA, that P, now P is the probability of a female birth, that P is greater than 0.5. We're going to set alpha equal to 0.05. That's our usual practice, but it could be set differently. It's not in this case. We'll set alpha equal to 0.05. Now we need a test statistic. That's going to be a random variable's distribution, and the random variable has to help us decide between these two hypotheses, between H0 and between HA. Well, here's what we propose. P hat minus P divided by the square root of P hat times Q hat over the square root of n. Now, we recall that this statistics, which we saw when we were talking about proportions, this statistic will have a z distribution, standard normal, a z distribution. The mean of the random variable P hat is just P, so this is a random variable minus its mean, and then we've seen this is the standard deviation. So that's going to have a z distribution. Now, if P is about 0.5, then P hat is going to be about 0.5. So the numerator is going to be very close to 0. Divide something by 0, you get something close to 0. A value of z close to 0 is going to make me think H0 is probably true. HA should be rejected. But if p hat was, let's think about extremes. Suppose 90% of the time that we have female births whenever we use XORT, then p hat would be about 0.9 minus the p. This p we always take from the null hypothesis. So this would be about 0.9 minus 0.5, or a 0.4 in the numerator. And that means that z is going to be a positive value and out toward the right-hand end of the distribution. If that happens, it makes me think that H naught is probably not true, that HA is more than likely the true state of nature, and I'll be rejecting H naught. Now, we'll say that over and over, and you'll read that in your text, but that is the basis of a hypothesis test. Now, suppose that we follow 100 couples that are using XORT, and we find that these 100 couples, 58 of the couples have female births, girl babies. That's more than a half, and so it's sort of looking good for HA, isn't it? It looks like XORT may be working, but I would not expect, if there is no change, that is, if natural birth is taking place, we say about half the births will be female. That doesn't mean every time I have 100 births, I'm going to have 50 female and 50 male. No, it means that the long-term average is about 0.5. And so it's quite possible that in any given 100 births, more than 0.5 will be female. So the question is, how surprising is having 58 births or more, 58 or more female births out of 100? So here's what we would have. We'd have that p hat is 58 over 100, which is 0.58. N is 100. Q, this would be the probability observed of having male birth, but it's 1 minus p hat, so that would be a 0.42. So here's what we've gathered from our sample. Now that means that we can calculate an observed value of z. And I don't know when I started doing this, but it was a long time ago, but I started putting a little star on the observed value of z. So z star in this case, just fill in here with the values that we got from our sample, would be 0.58 minus 0.5. This value comes from the null hypothesis. 0.58 minus 0.5 over, and this would be the standard deviation of p hat. 0.58, 0.42, 100, take the square root, that's 1.6. So that's the observed value of z. Now, we're going to find something else, a new term. We're going to find a p-value for this test. And this p is certainly is not the same as either of these p's. This is sometimes called a prob value, or the p-value of the test. And so the p-value is, by definition, the probability that z is greater than the observed value of z, which would be the probability that z is greater than 1.6, because 1.6 was our observed value. And the probability, and I did this using my calculator, but you could use Minitab to do it, the probability that a normal 0, 1, which is a standard normal, which is a z, the probability that a z exceeds 1.6 is 0.055. So the p-value is in fact greater than alpha. Remember, we've taken alpha equal to 0.05. So if the p-value is greater than alpha, then these results are not unusual. And if they're not unusual, I'm going to fail to reject the null hypothesis. The data that we've looked at doesn't give me sufficient evidence to think that p, the probability of a female birth, is any greater than 0.5, which it has been since the dawn of man, I suppose. So that's our first hypothesis test. Now, that's what I would call doing one by hand. Let's use Minitab and see what it looks like if we run the same test using Minitab. Let me pull Minitab up for us. So here's Minitab, and now we want to do a hypothesis test, our very first hypothesis test, using Minitab. So we're going to go to Statistics, and we will use Basic Statistics. And on the Basic Statistics menu, there's a test for one proportion. You see that that's really what we're doing. We're talking about the proportion of female birth. And I'm not comparing two proportions. I'm just testing one proportion. So here's the menu for a test using one proportion. Now, do we have samples in our columns? No, we don't have any data in our columns, but what we have is a summary, set of summary data. So Minitab wants to know the number of events. That is, how many successes did we have out of all of our trials? Well, we had 58 successes. I typed that in a little while ago. So our number of events is 58, and the number of trials was 100. We followed 100 couples. And we want to perform a hypothesis test. And so we'll check the box, Perform Hypothesis Test. And over here we've got to have our hypothesized proportion. And that would mean the null hypothesis proportion. And that one's 0.5. Now let's go to Options and see what kind of options we need to select from. Well, I see that I have a confidence level. This would be 1 minus my alpha. And if I want alpha to be 0.5, then my confidence would be 0.95. Notice that Minitab is taking this as a percent. So not 0.95, but 95.0. And my alternate hypothesis, we're looking at p greater than 0.5. So the alternate hypothesis is that the true value of p is greater than what's shown in the null hypothesis. The other possibilities would be less than or equal to, but for this application, greater than is the alternate. And then let's say OK. And then come back over to the first menu, and now we've selected our options, we've given summary statistics, we've said we want a hypothesis test, we're ready to say OK, and bingo, here's the result. And let's just read this. This is a test of p equal 0.5, that's a null hypothesis, versus p greater than 0.5, and that's the alternate hypothesis. Our sample, X was equal to 58, that is, we had 58 female births. N was 100. Our sample proportion, that would be 58 over 100, was 0.58. And our exact p-value was 0.067. Now the p-value is greater than our alpha, and so we're going to again fail to reject the null hypothesis. The p-value tells me how surprising the results were. Greater than alpha, not very surprising, and so we'll fail to reject the null hypothesis. So that's a test for one proportion. Now you need to practice that. There'll be homework problems, and there will be reading out of your textbook. But if you read your textbook, watch the video, do your homework, you'll have this down in no time. So, thank you for watching.